My name is Teovo Montaini from the Zone Creative company in Arezzo. I'm going to present the machine called AVA3, which is capable of creating various mesh shapes with wire from various materials through the use of PLC software. AVA3 comprises a mechanical part and a software part, and a wire straightener, wire traction motor named M2, which has the function of pulling the wire, motor M1, which has the function of folding the wire, motor M3, which has the function of cut regulation and comprises a circular saw, pneumatic clamp group for blocking the mesh during the cutting phase with the saw, pneumatic cutting group, regulation screw for Z-axis of M1 motor, equipment mounting. The equipment is composed of 4 wire traction rollers, 1 grommet, 1 shaped pin, 1 folder bearing, and 2 runners. If we want to change the section and measure of the wire or tube, it is necessary that we change the equipment we have just described. We insert the 2 runners.
E blocchiamo con apposita vite.
We mount the 4 rollers with the following specifications: the ones with the plus sign towards the left, and the ones with the minus sign towards the right. We block them with their screws. We insert the folding pin in the appropriate slot and leave it free. We insert the grommet. As you can see, it has 2 position settings. It is usually used in the position that is furthest from the folding pin. We block it with the appropriate screw. We insert the wire till it exits the grommet, taking care to regulate the wire straightener with the correct pressure.
Facciamo scorrere il filo fino all'uscita dal passafilo.
We block the wire with the specific handle and the correct pressure. We loosen the screws of the folding head, and with the appropriate register we look for the exact height until the exiting wire touches the pin correctly. At this point, it is important to note the value indicated on the comparator because it is important to restore it every time we remount the same equipment. We block the 2 previously loosened screws. We block the previously inserted pin with the appropriate dowel. We loosen the sleigh with the appropriate dowels. We insert the folder bearing in the appropriate hole and find the correct alignment with the wire, and we block it in this position with the appropriate dowel. We take our 0.5 mm washer and we insert it between the bearing and the wire. At this point, we block the sleigh and the 2 dowels. Now, the equipment is mounted correctly. Let's rotate the folding head towards the left and turn on the machine. The home page is visualized automatically. The home page shows the program that is presently in use. The piece counter, where we will set the pieces that we want to produce. Cut yes and cut no, which in this moment we will leave in cut no. The 0 plus button, which has the function of bringing the head back to its point of origin. 0 minus button, which has the function of bringing the head to its inverse point of origin. This setting is used in very special cases. Cycle on has the function of activating the machine, and cycle off of stopping it. Let's press the menu button, from which we can turn on all the pages of the machine. Home page, just analyzed. Recipes, which has the function of loading and saving the programs. Parameters is for expert users. English, Italiano allows us to change the language in the software. Cut setting, which has the function of activating and setting the available cuts. Set and test motor, which has the function of manually moving the motors. Ovals is a function for expert users which allows us to create ovals continuously. Alarms, where it is possible to see the eventual alarms. Work program, where we will see our program. Let's look at set motor. It is very important not to change the present values, otherwise the machine will not operate correctly. The buttons JOG plus and JOG minus of motor M2 move the wire forward with plus and backwards with minus. With the button JOG plus and JOG minus in M1, we manually intervene on the degrees of folding, increasing or decreasing them. We must always remember to press the button 0 plus, because if the head doesn't return to its initial position, the machine doesn't work. Finally, with the option Go Quota, it is possible to set a precise degree of folding. For example, let's enter 30 degrees, and by repressing Go Quota, we will see the head position itself at the set angle. The option we will use most often will be JOG plus in M2. Let's look at recipes. The machine presents 20 already programmed recipes, which we can open by using the button below. It is possible to save up to a maximum of 50 recipes, which we will now see by means of the appropriate button. How do we load them and save them? By means of the up and down arrow buttons, we select the recipe. For example, number 1. And with the load button, we load it correctly. With the save button, we memorize the recipe. With the button User SD, it is possible to save up to 6,000 recipes in an external memory. Let's look at alarms. In the alarms section, we have multiple options. Emergency OK. We press the red button to go and verify its operation. Wire OK. The machine stops by itself as soon as the wire is finished, and this is its indicator. Program OK. If the program has wrong values, the machine stops automatically. Let's look at parameters. This option is protected by a password, and it is only for expert users on request for assistance. At this point, let's see our work program page. With this machine, we can make various mesh shapes, which we will divide into two main groups. Standard shapes, such as squares, rectangles, triangles, hexagons and rhombus, oval and round shapes, that is, shapes with calendaring. Let's start to explain the standard shapes by loading the base program, which will have all values at 0. Our work page is divided into 6 columns named as follows: M1 wire folding, M2 millimeters wire feeding, cycle number repetition of row, increment is an advanced option, speed, which may vary from 1% to 100%, and 0, which can be set with value of 1 or 0. Standard group shapes. Let's build a first shape, for example a square with a 10 mm side. Keep in mind that the machine starts with motor M2. Therefore, we set in the M2 box the length of our side equal to 10 mm. After this, we set the folding angle in the box M1. In this case, it is a square. It will be 90 degrees. In the cycles box, we set the number of repetitions to form our square. That is 4. Increment, we leave the value 0. Speed, we set a low value such as 5%. Which we advise you use every time you create a new shape. And in the 0 box, we set the value 0, which has the function of automatically returning the motor M1 to its point 0. We close our program with the value 1 in the cycle box under the last completed line. We set a quantity of pieces required from the piece counter box, remembering that with value 0, the machine will produce meshes in continuation. Therefore, we enter the value 1. We return to the work page and press in sequence the buttons 0 plus, off and on. As we can see, the machine starts its set programmed cycle. When we check the meshes that we have just made, we can see that the set folding angle is not sufficient to obtain a perfectly aligned square. This is due to the fact that the wire has a certain amount of elastic resistance. Therefore, we must correct the folding value in M1 until we get a correctly aligned spiral. If the spiral of a mesh turns towards the right, we must increase the M1 value. Vice versa, we must reduce it. At this point, our shape corresponds perfectly to what we wanted, and we can save it through the following recipe button. We can set a free program number, for example 30, We enter a description such as 10 mm square. By means of the indicated button, we will save it. This procedure must be repeated every time we want to save a new program. Let's load our zero program so that we can create a new shape. In this case, we will create a triangle with a 12.5 mm side. We therefore set 12.5 mm in the M2 field . In the M1 we set 120 degrees . Cycles 3, increment 0, speed 5%. 0, we always leave the value at 0 because in all our standard shapes the motor M1 must automatically return to its point 0. We close our program with value 1 in the cycle box under the last compiled line. 0 plus, off, on. The machine is producing our triangle and, as you can see, even in this case, an increase in the degrees of the M1 field is required. In this case as well, we increase the value up to 125 degrees, which allows us to obtain an aligned spiral. In these two examples that we have just explained, we have equal angles and sides. Let's now pass on to shapes that have the same angle but different side lengths. M2 20 mm, M1 95 degrees, cycles 1, speed 5%, 0 value 0. We go to the following line to enter the other side. M2 10 mm, M1 95 degrees, cycles 1, speed 5%, 0 value 0. We go to the following line to enter the other side. M2 20 mm, M1 95 degrees, cycles 1, speed 5%, 0 value 0, and we go to the following line to enter the other side. M2 10 mm, M1 95 degrees, cycles 1, speed 5%, 0 value 0. We close our program with the value 1 in the box of the cycle under the last compiled line. 0 plus, off, on. Now we go to shapes with different angles and same side lengths, for example, a 15 mm side rhombus. M2 15 mm, M1 65 degrees, cycles 1, speed 5%, 0 value 0. We go to the following line to enter the other side. M2 15 mm plus 3 mm. Add the material of the spine diameter because on important folds we lose part of the set material. M1 95 degrees, cycles 1, speed 5%, 0 value 0. We go to the following line to enter the other side. M2 15 millimeters, M1 65 degrees,
65 gradi,
cycles 1, speed 5%, 0 value 0. We go to the following line to enter the other side. M2 15 millimeters plus 3 millimeters, M1 95 degrees, cycles 1,
velocità.
speed 5%, 0 value 0. We close our program with the value 1 in the box of the cycle under the last compiled line. 0 plus, off, on.
Nel nostro programma abbiamo inserito un lato più lungo di 3 mm in quanto quando la macchina fa questa piegatura più accentuata.
With this information that we have just explained, you will be able to start to get comfortable with the machine for standard shapes. We now need to have curved sides. Therefore, we will explain how to go about this. 10 millimeter circle. M2 value 0.01 millimeters. M1 example 50 degrees.
50 gradi.
Cycles 1. Increment 0. Speed 5%. 0 value 1. In this way, the wire traction motor is stopped. Then the folding head M1 arrives at the set 50 degrees, but with value 1 in the 0 field. The head will stay still at 50 degrees. In the following line, we set the material for our 10 mm circle. But to do this, we need to execute a mathematical calculation. Internal diameter 10 millimeters plus wire size 1.20 millimeters, therefore 11.2 millimeters multiplied by 3.14 equals 35.17 millimeters. M2 35.17 millimeters. M1 value 0. Cycles 1. Increment 0. Speed 5%. 0 value 0. We have set a 0 value because once the machine has completed our circle, the folding head will automatically return to point 0. We close our program with value 1 in the cycle box below the last compiled line. At this point, the certain datum is the set length in M2 value, because the degree we set in the M1 field must eventually be corrected till we obtain the required 10 mm diameter. We set in our piece counter the value 1, then we return to our work page.
Per poi ritornare alla nostra pagina di lavoro.
0 plus, off, on. We check the shape produced and, as we can see, our circle doesn't have a 10 mm diameter, but it has a 6.98 mm one. Therefore, we must reduce the folding value in M1 because by reducing this value, we will have a larger circle diameter. Vice versa, we will have a smaller one. Let's therefore try to set 50 degrees instead of a value of 40 degrees. 0 plus, off, on. It is important to remember that the maximum value we can set in the M1 field is 80 degrees. As we can see, our circle corresponds to the 10 mm diameter. 18.5 mm circle. Having a larger diameter, we must certainly reduce the degrees in the M1 field. M2 value 0.01 millimeters. M1, for example, 30 degrees.
30 gradi.
Cycles 1,
1.
increment 0,
Velocità
speed 5%, 0 value 1.
Sulla colonna 0, 1.
In the following line, we set the material of our 18.5 millimeter circle. Internal diameter 18.5 millimeters, plus wire size 1.20 millimeters, therefore 19.7 millimeters multiplied by 3.14 equals 61.86 millimeters. M2 61.86 millimeters, M1 value 0, cycles 1, increment 0, speed 5%, 0 value 0. We close our program with value 1 in the cycle box below the last compiled line. 0 plus, off, on. We check the shape produced, and as we can see, our circle doesn't have an 18.5 diameter, but one of 15.3 millimeters. Therefore, we must reduce the folding value on M1. We set the value of 28 degrees.
Impostiamo il valore di 28.
0 plus, off, on. As we can see, our circle corresponds to an 18.5 millimeter diameter. Oval. An oval is composed of two diameters and two different lengths. It is easier to obtain the diameters and lengths by means of a design software, AutoCAD. If you don't have a design software, you can proceed in the following way. First, we build two circles, one of 10 millimeters and the other of 18.5. Then we'll try to unite the two different diameters in order to obtain an oval shape. M2 value 0.01. M1 28 degrees.
28 gradi.
Cycles 1. Increment 0. Speed 5%. 0 value 1. In the following line, we will enter a length of about a quarter of the total length. Therefore, 61.86 divided by 4 equal to 15.46 millimeters, which we then round out to 15.50 millimeters. M1 0 degrees, cycles 1, increment 0, speed 5%, 0 value 0. In the following line, we enter a different diameter. M2 value 0.01, M1 40 degrees, cycles 1, increment 0, speed 5%, 0 value 1. In the following line, we will enter a length of about a quarter of the total length, 35.17 divided by 4, therefore equal to 8.79 millimeters, which we then round out to 8.5 millimeters. M2 value 8.5, 0 millimeters. M1 0 degrees, cycles 1, increment 0, speed 5%, 0 value 0. We close our program with value 1 in the cycle box below the last compiled line. With this kind of program, we have created half of our oval. Therefore, on our piece counter, we will insert a value of 2 to get a complete oval. 0 plus, off, on. We check our oval and we see how it is aligned. Vice versa, as in the standard shapes, we must increase the folding angles M1 in both of the entered angles. We advise you to load our saved programs for ovals and then correct them always in the M1 value as explained. This procedure will allow you to become comfortable with the machine and to start to make your own ovals. Creative shapes. Starting from our ovals program, by simply increasing the length of the M2 field of the two different circles, we will have the possibility of creating various fancy shapes. Example, we increase the first value M2 from 15.5 millimeters to 32 millimeters, and the second value M2 from 8.5 millimeters to 10 millimeters. We go to home page to change the piece counter from a value of 2 to 10. We check our program, 0 plus, off, on. As you can see, by changing only this one of the two parameters, we have obtained a shape that is similar to a flower. Therefore, by keeping in mind what we have said, you can give shape to your fantasy. Spiral cutting group. As you can see, the machine is equipped with a cutting group with knives called spiral. This group allows us to cut mesh spirals in various lengths. This cut requires the use of compressed air at a minimum of 6 bar. Let's go to the menu page. We select the cutting settings for 5 meshes. Once inside, we set our values. By pressing the No Cut key, we activate the cutting group. By pressing the Spiral key, we select the kind of cut required. In this case, a spiral. In the Cycles field, we enter the value 5. In the Wire Advancement field, we enter the exact wire advancement that we need to cut. In this case, 75 millimeters. In the Wire Retraction field, we enter the exact wire retraction up to the starting position. In this case, 55 millimeters. In the Saw Advance field, millimeters, we enter the value 0 as we won't use it. In the Saw Advance Speed, we enter 5 as we won't use it. In the Pincer Pause field, we set the value 0.5, which must never be modified. Test Cut key. Having previously entered the correct values, we will simulate a single cut. Now, we will show you an example of a spiral cut in the 10 mm square program. Remembering to increase the repeat value up to the number of the required pieces. In this case, 5. Remember that once you have entered the correct cutting data for a specific shape, when you save the program, as previously explained, the entered cutting settings will also be automatically saved. Let's see how the program works. Should we want to pass from a spiral cut to a saw cut, we must substitute the following cubes, while cutting off the air inside the machine. As you can see, the machine is equipped with a cutting group with a motorized saw called saw cut. This group allows us to cut meshes individually with a very high quality of cut. We choose the cut settings. By pressing the no cut key, we activate the cutting group. By pressing the spiral key, we choose the kind of required cut. In this case, saw. In the cycles field, we always enter the value 1. In the wire advancement field, we enter the exact wire advancement that we need to go and cut. In this case, 0. In the wire retraction field, we enter the exact wire retraction up to the initial position. In this case, 0. In the saw advancement field, millimeters, we enter the value required to be able to completely cut the wire, in this case 28 millimeters. In the saw advancement speed field, we enter a value that may vary from a minimum of 10 to a maximum of 40, in this case 20. In the pincer pause field, we set the value 0.5, which must never be modified. Test cut key. Having previously entered the correct values, we will simulate a single cut. We load the 20mm round program and we try to cut it, keeping in mind that we must go to the home page and define the value of required pieces, for example 2.
Torniamo nella nostra pagina programma.
It is very important to mechanically set the saw cut. With this screw on this knob, we set the saw height. By loosening this screw, we set the saw inclination. By loosening this knob, we set the carriage group. While we can use this arrest stop as a reference for the points used.
Dobbiamo regolare il gruppo pinza che attraverso quella vite mi permette di regolare l'altezza dello stesso.
With this last screw, we can regulate the opening of the pincer group.
Andiamo a regolare l'apertura del gruppo pinza.
The machine can work both with wires and filled tubes of whatever cross-section, round, square, oval or semi-round, from a minimum thickness of 0.5 millimeters to a maximum of 4 millimeters. Thank you, and I wish you good luck.